And now I have to finish this by a big disclaimer. Dynamical systems, as they're taught to you by Strogatz and likes of Strogatz, are a fraud, because people who teach courses often don't do the work, and we don't do anything that I described to you so far. Well, I haven't integrated. So Newton says, and more sophisticated formulation, Euler, says that, I should start someplace and I should just receive my infinitesimal orders and I should throw my boomerang with such precision, for example, 10 to the minus 14 precision in my 3 directions and 3 velocities in initial conditions. That's going to fly out of your classroom, go to the next classroom, whirl there, come back, and land in your hand. So, that's what we tell you we are doing. But of course we can't do this. This is just a lie. This is impossible. What do we actually do? That was done by a working person called Lagrange. French Revolution and all that. And what Lagrange says, they teach you this in mechanics course, but you never understand why. But this is what he actually says. I want to go to that room, and come back. So I give you itinerary of points where I want to go. That's what I want to do. And I know that the law is flexible enough to allow this. Then what Lagrange says, put a rubber band between these points. So it's supposed to be a curved line, but this is, pretty crude approximation. That's called a global orbit of the thing. So you put the rubber band there. And then you tighten it. What you mean by tighten it, you make sure that every place along the way, it actually follows the local law. That's called Lagrange-Euler equations in mechanics. And I don't need 10 to the 14 precision to do this. I can do a good job by 5% if I'm doing an engineering problem and I'm trying to produce, the fuel consumption to 5%. So that's what we really do, but nobody tells you except in this course. I'm done for today. Because I'm professor, I screwed up, so there was no discussion. But that was not the idea. On Tuesday, it'll be all discussion and a little bit blah, blah. In what sense I tighten this thing. So if I'm in the billiard, then the sections between bounces of the billiards are straight. I'm moving in free motion. So tightening really means the rubber band. But if I want some curved potential landscape, then the rubber will have to go up and down, and it'll be the shortest possible rubber on it's called a geodesic, on a curved landscape. And if I have an intelligent idea of a topology of the space, geometry of space, I'll just give you itinerary of things you have to do. Go here, go there, talk to the chair, talk to the financial office, and come back home and bring the bacon. And, you will do the best job getting around, and you'll choose a geodesic. You actually have no choice but moving on geodesic. But in dynamical systems, the geodesics might be isolated and well-defined, so that we'll learn later. But that's really what goes on. You should act locally, meaning you have your local little map saying, if I move this way, this has to move that way. That's called a differential equation, a partial differential equation. And then you follow it. But you know what you have to do. That's a global thing. So you do a crappy job of doing your thing, and then you improve it and you publish it.